Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the earlier videos of geometry where I have covered many concepts of triangles like congruent and similar triangles, geometric centers of triangles and so on. And quadrilaterals like parallelogram, rhombus, trapezium, etc. In case if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to see what a polygon and its properties, and we'll be also seeing what are regular polygons. So let us begin with today's video. Any closed figure with 3 or more sides can be termed as a polygon. For example, a triangle which has 3 sides can be termed as a polygon. In a similar way, a quadrilateral which has 4 sides can also be termed as a polygon. We also have polygons with 5 sides, 6 sides, 7 sides, and so on. 5-sided polygon is known as pentagon, 6-sided polygon is known as hexagon, 7-sided polygon is known as heptagon, 8-sided polygon is known as octagon, 9-sided polygon is known as nonagon, and 10-sided polygon is known as decagon, and so on. So, a polygon is a closed figure with 3 or more sides. Now, there are two types of polygon, convex polygon and concave polygon. A convex polygon is a polygon in which each interior angle of the polygon is less than 180 degree. For example, here I have drawn a polygon with 4 sides such that all the interior angles are less than 180 degree. So, this polygon can be termed as a convex polygon. A concave polygon is a polygon in which at least one of the interior angle is more than 180 degree. For example, in this polygon, this interior angle is more than 180 degree. So this polygon can be termed as a concave polygon. Also, any straight line drawn cutting a convex polygon will be passing only through 2 sides of the polygon. Whereas in a concave polygon, it is possible to draw a line passing through more than 2 sides of the polygon. So, a convex polygon is a polygon in which all the interior angles are less than 180 degree, whereas a concave polygon is a polygon in which at least one of the interior angle is more than 180 degree. Now, the sum of all the interior angles of a polygon with n sides is given by 180 into n minus 2 degrees. For example, if you are considering a pentagon with 5 sides, in that case, the value of n would be 5. So, the sum of all the interior angles of pentagon would be 180 into 5 minus 2, that is 180 into 3, which would be 540 degree for a pentagon. In a similar way, we can find the sum of all interior angles of hexagon, heptagon, octagon, nonagon, decagon, and so on. Also, the sum of all exterior angles of a polygon with n sides is given by 360 degree. That is, the sum of all exterior angles of a polygon is independent of n, that is the number of sides. So, the sum of all exterior angles of pentagon, hexagon, heptagon, octagon, and so on is always 360 degree. So, the sum of all interior angles of a polygon can be found out simply by using this formula, which is 180 into n minus 2, where n is the number of sides, and the sum of all exterior angles of a polygon is always 360 degree, which is independent of the number of sides. Now, let us see what is a regular polygon. A regular polygon is a convex polygon in which all the sides and angles are equal. For example, if we consider a polygon with 3 sides where all the sides are equal and also all the angles are also equal. Then this polygon can be termed as a regular polygon. And we know that in a triangle, if all the sides and angles are equal, then this triangle is known as an equilateral triangle. So an equilateral triangle is a regular polygon. In a similar way, if we consider a polygon with 4 sides where all the 4 sides are equal and also all the 4 angles are equal, then this would be a regular polygon, and this is a quadrilateral, and this quadrilateral is known as a square. So a square is also a regular polygon. In a similar way, if we have a hexagon where all the angles are equal and all the 6 sides are also equal, then this hexagon can be termed as a regular hexagon, and so on. So if all the sides and angles of a polygon are equal, then the polygon can be termed as a regular polygon. Now, since the sum of all the interior angles of a polygon with n sides is given by 180 into n minus 2. So for a regular polygon where all the sides and angles are equal, in that case, each interior angle of a regular polygon with n sides can be written as 180 into n minus 2 upon n. So for a regular pentagon, each angle would be 180 into 5 minus 2, that is 3 upon 5, which would be giving us 108 degree. That is, each angle of a regular pentagon would be 108 degrees. In a similar way, for a regular hexagon, each interior angle would be 180 into 6 minus 2, that is 4 upon 6. And this would be giving us 120 degree. That is, each interior angle of a regular hexagon is 120 degree. So in this way, simply by using this formula, we can find the interior angle of any regular polygon. Also, since the sum of all the exterior angles of a polygon is 360 degree, so each exterior angle of a regular polygon would be 360 upon n, that is the number of sides. So for a regular pentagon, each exterior angle would be 360 upon 5, which would be 72 degree. In a similar way, for a regular hexagon, each exterior angle would be 360 upon 6, which would be 60 degree, and so on. So in this way, by knowing these formulas, we can find the interior or exterior angle of a regular polygon. Now say if it has been given that for a regular polygon, each interior angle is given to be 162 degree, and we need to find the sum of all the interior angles for that regular polygon. Since we know that each interior angle of a regular polygon is given by 180 into n minus 2 upon n, and this angle is given to be 162 degree. So we can equate these two and we can find the value of n. But this would be a little bit time consuming. So instead of using the interior angle formula, we can directly use the exterior angle formula, which would be much simpler to use. As if each interior angle is 162 degree, in that case, each exterior angle would be 180 minus 162 degree, which would be 18 degree. That is, each exterior angle of that regular polygon is 18 degree. And we know that each exterior angle is given by 360 upon n. So this angle would be equal to 360 upon n, from which we'd be getting the value of n to be 20. That is, the number of sides for that regular polygon is 20. Now, each interior angle of that regular polygon is 162 degree, and we know the number of sides in that regular polygon is 20. So the sum of all the interior angles can be written directly as 162 degree times 20, which would be giving us 3240. So In this way, instead of using the interior angle formula, we can directly use the exterior angle formula to find the number of sides and then to find the sum of all interior angles for a regular polygon. Now, let us see some important length and area of a regular hexagon. Here, I have drawn a regular hexagon A, B, C, D, E, F. Since this is a regular hexagon, so all the sides and angles would be equal. Let us assume each side to be of A units length. And we know for a regular hexagon, each angle is 120 degree. So all these angles would be equal and would be equal to 120 degree. To find the area of this regular hexagon, I have divided this hexagon into 6 congruent triangles by joining the vertices C and F to form the diagonal CF, by joining the vertices B and E to form the diagonal BE, and by joining the vertices A and D to form the diagonal AD. All these diagonals meet at a point which is the center of the hexagon. Let us denote this point by O. Now, this angle is a complete circle which would be 360 degree. So all these angles will also be equal and would be 1/6 of 360 degree, that would be 60 degree each. So all these angles would be 60 degree. Now, if we consider triangle OAF, in that case, this angle is 60 degree. The side OF is equal to the side OA. So this angle will also be equal to this angle. And since this angle is 60 degree, so these two angles will also be 60 degree each. So triangle OAF would be an equilateral triangle where each side is of A units length. Now we know for an equilateral triangle, the area is given by √3/4 into side square, and here the side is A, so this would be √3/4 into A square. We can also find the area of the triangle OAF simply by using the formula for the area of the triangle as half into product of the two sides into sine of the angle between them. Here, the two sides can be considered as A, and the angle between them is 60 degree. So the area can also be written as half into A times sine of 60 degree. And we know sine of 60 degree is √3/2. So this would be also giving us the area of triangle OAF as √3/4 into A square. In a similar way, the area of the other 5 triangles will also be √3/4 into A square. So the area of this regular hexagon would be 6 times the area of this triangle, which would be √3/4 into A square. So this would be giving us 3√3/2 into A square. So if we know the side of a regular hexagon, we can find its area simply by using this formula, which is 3√3/2 into side square. In a similar way, we can find the area of a regular polygon of n sides by dividing the polygon into n congruent triangles, just like we did for a regular hexagon, by joining the vertices of the polygon with the center of the polygon. And in general, the area of a regular polygon is given by n into r square upon 2 into sine theta, where n is the number of sides of the polygon, r is the distance between the center of the polygon to any vertex, and theta is given by 360 upon n. For example, if we want to find the area of a regular octagon, in that case, the number of sides would be 8. So using this formula, we can write it to be 8 into r square upon 2 into sine of 360 upon 8, which is 45. And we know the value of sine 45 degree is 1 by root 2. And if we know the value of r, we would be able to find the area of a regular octagon. So whenever we need to find the area of a regular polygon, we can directly use this formula. Also, there are total 9 diagonals in a regular hexagon, out of which 3 are longer diagonals, which are AD, BE, and CF, and 6 are shorter diagonals, which are AE, EC, CA, and BF, BD, and DF. The length of the longer diagonal would be A plus A, that is 2A, that is 2 into side, and the length of the shorter diagonal is root 3 times the side. Well, here I haven't shown how we have found out the length of the shorter diagonal to be root 3 into side. But if you guys are interested, you can join the shorter diagonal AE and can use the cosine formula or 30, 60, 90 degree approach to find the length of the shorter diagonal, which would be root 3 times the side. But my suggestion would be to simply remember these lengths, which would be sufficient. So the area of a regular hexagon is given by 3 root 3 upon 2 into side square. And in general, the area of any regular polygon is given by n into r square upon 2 into sine theta, where n is the number of sides of the polygon, r is the distance between the center of the polygon to any vertex, and theta is given by 360 upon n. Also, there are total 9 diagonals in a regular hexagon, out of which 3 are longer diagonal and 6 are shorter diagonal. And the length of longer diagonal is given by 2 into side, and the length of the shorter diagonal is given by root 3 times the side. Now, let us see how we can find the number of diagonals in a polygon. The number of diagonals in a polygon with n sides can be found out simply by using this formula, which is given by nc2 minus n, which when we simplify can be represented as n into n minus 3 upon 2. For example, for a hexagon which has 6 sides, the number of diagonals would be 6 into 6 minus 3 upon 2, that is 18 by 2, which is 9. In a similar way, for an octagon which has 8 sides, the number of diagonals would be 8 into 8 minus 3 upon 2, which would be 40 by 2, that is 20, and so on. This NC2 here simply means the number of ways of choosing 2 things out of n things. In general, it is given by NCR, whose formula is n factorial upon r factorial into n minus r factorial, which simply gives us the number of ways of choosing r things out of n things. Well, we'll be discussing in more details about this NCR thing in the permutation and combination chapter. But for the time being, simply try to understand what this NC2 means. So, number of diagonals in a polygon with n sides can be found out simply by using n into n minus 3 upon 2. Now say we have been given this question that there is a convex polygon which has 54 diagonals, and we need to find the number of vertices or sides that this convex polygon have. Well, to find the number of vertices or sides, we can directly use this formula, which would be n into n minus 3 upon 2. And since this gives us the total number of diagonals, so this can be equated to 54. Now, this would be a quadratic equation, and when we solve this, we'd be getting the value of n to be 12. So, the number of vertices or the number of sides that this convex polygon has is 12. So in this way, we can directly use this formula to find the number of vertices or sides. So that's it for today's video, in which we have seen what are polygons and its properties, and we have also seen what are regular polygons like regular hexagon and so on. And in the next video, we are going to start with circles and its properties and some important theorems. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing and keep growing. Thank you.